All right. We are doing the Atwood machine problem. We've done this one before, but they just try to sort of stretch it out and do quite a bit with this. One thing we want to note is that M1 always is less than M2 as far as the mass goes. So what that means is that in this case, M1 will be pulled up by the tension. So let's actually just get a couple things established. I'm going to make the tension force 3 squares long, or 3 ticks long. For both of these, since the tension force is equal in the Atwood's machine, we got to be absolutely clear on that. And then the next thing I want to note is, well, we need things to fit, so sorry. Let me start again. We're going to make it 2 ticks long. Again, because in these Atwood machines, the tension is always equal. Now here's the thing. We know that M2 is going to win this kind of tug of war. So we'll have its weight, and then M1's weight, something like this. All right, and what we're going to do is we're going to now prove the acceleration formula. So we've done this before, so once again, Ft minus M1g equals M1a, and M2g minus Ft equals M2a. What I'm going to do is I'm going to add these two equations together, and that's going to get me that M2g minus M1g equals M1 plus M2 times a when I add those equations together. And so that's how I'm getting this result here. I know a lot of you would be tempted to do the same thing. Let's actually write it out by dividing. So we get M2g minus M1g over M1 plus M2. Then we'll go ahead and factor M2 minus M1 times g over M1 plus M2. That's actually how they would want you to write the answer in the proof out. All right. For part C, we have various accelerations and M1s and M2s, and we want to know what is it that we would need to graph in order to get a numerical value for gravity. So let's just be clear. The acceleration, again, we got that it's M2 minus M1 over M1 plus M2 times g. So if we plot this as our x-axis and this as our y-axis, g would be the slope. So our vertical axis should be a, and a horizontal axis should be M2 minus M1 over M1 plus M2. And I'll leave it to you to actually fill in this data table, but when you do, I don't think you're going to get a slope that's perfect, but one thing I'd recommend, though, for your scale, I would set this maximum to 5, and I would set this maximum here to 0.5. That'll actually help you. So I'll actually let you finish this part on your own, but I'll just put this out there. You'll get around 10, you'll get anywhere from 9.0 to 11.0 is what I'll say for your slope. Now, moving on, we ask if we keep M1 and M2 the same, how does the tension change? So I'm going to actually just go ahead and solve. So I know that T equals M1 times A, and I know that M2G minus T equals M2 times A. So what I end up getting from my acceleration when I actually substitute this into here is that A equals M2G over M1 plus M2. So when I get the tension here, I'm going to get T equals M1 times M2 times G over M1 plus M2. Now what I'm going to do is I'm going to go back and actually get the tension in the first part and just compare them. This is the brute force way of doing it. So the tension here, Ft equals M1 times M2 minus M1 over M1 plus M2 times G plus M1 times G. Okay, I'm just basically solving this thing and isolating the tension there. So let's compare these two forces. And if I wanted to give them a common denominator, I could say this is M1 plus M2 over M1 plus M2. So when I simplify this tension, what I'm going to get, well, that was gross. So M1 plus M2 over M1 plus M2, just writing it as 1 over 1. And then when we simplify this, we're going to get our tension equal to, so we're going to have 2 M1 M2 over M1 plus M2 times G when we simplify. So when we compare these two tensions, we're actually getting that the tension is lower in the second case. But let's actually talk about what this actually means. The real reason is that because M1's on the table, I don't know, for me, I would just actually just solve and prove it algebraically. So this is T in the second situation, and T in the first situation, I'm getting 2 M1 M2G over M1 plus M2, and I would just prove it mathematically like that. I know there's deeper ways to get to it, but I'm just going to go with that. The value determined for the acceleration to gravity is lower than in the first experiment. Give one physical factor that might account for that. This is probably the one time that friction with the table would actually explain that. All right, so that's problem number 1 for the mechanics part. We'll take a look at the second mechanics problem in a second.